Thanks, Nico. Great. Well, welcome indeed. Let's first start with a short introduction. Who are we? I'm Sven, CTO at Stacks.
I'm Jelle, product owner of MyStacks.
Where are we today? Hey, and what do we know? Not that much, apparently, as we learned this morning from Jeppe and Etzo. We're doing what we're doing, and let's figure it out. So, but also, key takeaway from that talk, context. And it also goes for agents in business context, and that's what we're going to show you some real-world examples today, how we use large language models, but also other AI components within the context of a business. And we're trying to explain here why that context, as discussed by Jeppe and Etzo also this morning on a more philosophical level, how you can make that practical and how you can use that in your AI-driven systems and processes. So, to unlock the full potential of your AI agents, whether it's a large language model or whatever AI component you're using, the context is king. So even the simplest business tasks only lives within their context. If you're trying to approve an invoice, you have to know the details about the invoice. You have to know what it is all about. If you have to write a document, you have to know what the context is. Why am I writing this document? What is it about? But one of the problems using generative AI is they're general. So we call them GLPUs, General Language Processing Units. So it's like a CPU, but only for language. They're very general. They can do all types of operations, but you really have to instruct them what to do. And we have different tools for them, and we will touch upon those tools in this presentation. One of them being the RAG, Retrieval Augmented Generative Tools, function calling, as well as combining all these tools into multi-agent systems. And we build up from these different tools throughout our presentation. So first of all, RAG. Last year I was presenting here, and I had this slide with me, and we would now say this is an ancient RAG. It's from 2023. It's like insane to me. 1 year ago, this was like state of the art, getting your data, using your corporate private data to build a conversational UI. And now we're here, and it's like an ancient first prototype of a RAG system, just in 1.5 years, something like that. And it consists of some important parts where you split your documents, and get back to that later, put it in a vector database, and use this vector database to generate your answers. And we had some simple reasoning models at the time. The things we were thinking about is like, hey, I have this context data, I put it in a prompt, I feed it into the LLM, and I get my answer. Second approach was like, okay, but maybe I get multiple chunks of text, and I have multiple LLMs providing the answer, feed all the answers into a last LLM and get a final answer. And also using more like MapReduce kind of structures and reiterative structures where you use continuously the same LLM to make it a bit smarter. This was really the things we were at the time in terms of state-of-the-art RAG systems. But I want to bring it a bit further today, like which technologies do we have now and how did we apply them in some real-life use cases. So one of our customers came to us and they had like 100,000 documents in their system, and they were like, okay, well, we want to ask questions about these documents, right? So similarly like we did last year, but really domain-specific languages. Like I have company A and I have company B. Is there like a electricity connection between the companies, or is one of them producing or using water? So producing water into a flow, and another company wants to use water. Questions like that, which are really, really domain specific. And on top of that, a lot of the documents in the corpus were questionnaires. So they were like documents they sent to their customers with questions, and they would provide answers like, are you using water? Are you providing electricity? Are you using electricity? Stuff like that. And were also the questions they were interested about in asking on these documents. So we first started with what we now call a naive RAG. So last year, state of the art now, naive RAG system. So we started with the documents, split them into chunks. Let me see if I can do the pointer. Feed them into the vector database, get the user question. Based on the user question, find out which chunks were close to the question of the user, get the top K chunks, feed them in the LLM and get a response. Awesome. This is where we were at the time. But the questions the answers to the questions, they were completely useless. We were basically getting the questions from the document set. So we got really strange answers to our questions. So if we would ask questions about which company is using water, we would get like the result in a questionnaire, but we wouldn't get the answers to the question we were asking. So we were like, okay, what's going on here? This used to work pretty cool in the other projects we've run, but this project ain't working anymore. So we went in front of a whiteboard and we thought about it like, okay, what's happening here? And to get a bit more in detail about it, we thought, hey, let's visualize what's happening. It's very important, especially in AI and working with large amounts of data, that you make a visual mental model. Especially if you know, and I skipped it in my initial slide last year, I told that ChatGPT or OpenAI use like roughly 1,540 dimensions for their vectors. And the vectors, they call it embeddings, is basically the representation of a chunk of text into a vector space. From the mathematical term we know it, but they use it over 1,500 dimensions. So we know 3, right? X, Y, Z, maybe 4. Put time into it and then it gets really hard. Try to figure out a 5th dimension, becomes even harder. Now it's 1,500. So I simplified it a bit for this talk, made it 2D. And as you can see here, if we ask a question, what colors do farm animals have, as an example, we would like to have answers from these types of text, right? Sheep are white, cows are usually a combination of blah, blah, blah. But what happens when you search in a vector database, this is a question and this is another question, and they resemble more closely than these. So you get like other questions as a result from your vector database instead of these. And we want to have these. So how did we approach this? We started to think differently, the other way around. So we have like these documents, we make chunks of them, and instead of putting these chunks into the database, we spun up a second agent, another large language model, which we instructed very specifically not to interpret these chunks and create answers, no, to think about questions we could ask about these chunks. So that's where we started. So instead of having the chunk in there, like cows are usually a combination of black and white, what question could you ask about it? What color does a cow have, as an example? So we started generating these questions, and we put them in the database. But still we got like pretty strange answers, because as we know now, LLMs are general purpose large language models. So they started generating general questions. Like, okay, what's the color of a cow? But we wanted to know things about, for example, water or electricity or the region. So we did an additional thing, and we trained it also with what are the topics you want to learn the system about. So we refined the whole large language, the model, to take into account like the chunks, generate questions for a specific topic. And that's quite a process you have to go through to get to the correct RAG system. But this is an additional thing we learned in building these type of systems. Like, okay, it's not only feeding in the chunks of the documents, but also start to think differently. In this case, it's about questions. So we started generating questions. And the code is rather simple. So in this process, you have to generate the questions. And the only thing we have to do is ask the user, what are the topics you want to ask questions about? Water, electricity, whatever. And then make a very simple prompt where you say, okay, generate an X amount of questions in a specific language. This was Dutch. So if you ask Dutch questions, it's easier to have the Dutch questions in your vector database. But let's say you want to do it in German, replace it with German. Do you want to ask simple question or really complicated questions? So we started with simple questions. And then you add like the topic instructions. So water, electricity, etc. And use the text of the chunk. And together we save them in the vector database. So you have the questions, you have the chunk, and you have the reference where it is in what document. And from there on, we could build up like the answers to the questions the user were asking. Hard part though was, how can we test if this is working? It's not like science, right? So you cannot just calculate this is the correct answer, especially not with that amount of documents. So what we did mainly is worked closely together with the domain expert. Initially, we tested ourselves. Does it make sense? That's the first iteration. Didn't. So we came up with the questions and the topics. And then we had the domain expert test driving the system. So it's not like you can really, in our opinion, fact-based check if it's doing the correct thing. You also have to have the human in the loop here to check if the system is doing what it's doing. So it's more empirical testing in our case than that it was more like a technical test where we could see like, hey, if we put A in, then we expect C to be out, and it was indeed C. No, we really had to have the user using the system to reiterate on this whole process. And then another interesting thing happened. They were expecting like answers we didn't get from the system. So upon exploration, figured out there were quite some images in the documents which were of quite value to them. So like graphs or photos or etc. So then we figured out like, okay, how can we use these images in our conversational UI, in our database? And that's where we bumped into more the classical AI, so to say. And we had a vision AI agent, in this case, an image captioning network, which looked at the image, generated an image caption, and we used the image and the caption to generate the questions, save them again in the database. So you would also get like images based on your questions, get the information from images. And where we started off with last year with like, okay, we have this document, we chunked them, we just put them in a database as questions, seems to work. We're now at a place where we're combining all these different tools and different processes of RAGs, other types of AI. So as an example, stuff we're also experimenting with is we now generated questions based on text. You could also flip it around. Do a question, generate hypothetical answers to these questions, and use that to search your vector database. That is also an interesting approach. We didn't use that one yet in this particular project, but that's also a very interesting way of building up your RAG system. Another one, which we'll get a bit more into in the next talk, is we also have a lot of structured data in our enterprise, in our corporations, in our companies, in our society. And we're now really focusing on the whole generative, more RD-like data and how can we use it in prompts and feed it in there. But there's a lot of information in all our systems which we can also use to feed the LLM to do very interesting things. But we can also use the LLM to search these systems. So as a pretty well-known example is who is the director of movie Y? Then you can ask it to the LLM and probably knows the answer because it knows quite a lot of information from the internet. But if you have an internal database, you can also have that user question fed into a particular large language model, which generates a graph query, for example, looks into your own graph database and feed it into an LLM to do all types of interesting things. So you embed the structured data as well in your whole RAG flow. And that brings us to where we are right now in terms of how we look into the whole AI ecosystem. First of all, you need your business context. What am I doing? What information available? Where is it available from? And build basically an AI orchestration tool which uses the LLM, a vision AI system, maybe the expert system, the structured data, maybe some object recognition tool, and start from there to generate all type of interesting new ways of looking at, for example, your business. And that's what we did in our next part of our talk. As some of you may know, we're building a MyStack system, and Jelle will tell more about it. And we used all these concepts to even more think about how you can design your business and improve the user experience, so to say, in our MyStack system. So I'm going to hand off the mic.
Oh, thanks, Sven. So Sven did take you through like this different variations of RAG and why context is actually important. And well, I will be taking you a little bit more through like how can we combine actually several tools around AI to show you a real world example how to do some stuff, which is generating a BPMN. So I want to build a BPMN generator. Well, and then I see most of you thinking, or probably most of you thinking, like, what the heck is BPMN? Well, it's business process model notation. And then you still think, what is business process model notation? Well, it's this. It's BPMN is like, well, it's a process And then here you start with this is a process of a bug fix, which most of you are probably familiar with. Here you start with, well, the bug is reported, and then you have like a task, which is triage it, and then, well, you check if it's fixable. This is a gateway. And then, well, when it's fixable, you go ahead, and when it's not fixable, well, then, of course, it just won't fix, and that's the end of the process, clearly. So this is a visual representation of a process, and it's something we want to generate. But BPMN is also, well, this is actually what's happening behind the scenes. This is BPMN. So this is an XML with a standard. And, well, I'm just going to walk over a little bit so I can point out better. That we have like two parts in this BPMN, which is important. So this first part you can see here, there's like the definition of for the computer, which is like the runtime stuff. This is where actually the tasks are linked to the correct flows, and the correct flows are linked to the correct gateways, etc., etc. So that's one part, but the other part is like the DI, BPMN DI, which is the BPMN diagram stuff. So you can also see there's also like a visual part in here. There's, for example, X and Y coordinates, where it is, width and height. So actually the BPMN consists of two completely separate things, but they're very interlocked with each other, etc., etc. And all of this comes back in like the specification, and I just checked the specification is 532 pages long. So I might make some mistakes here in this example. I'm sorry about that. But as you can see, the BPMN is rather like a very structured, deterministic thing. But, well, we want to generate it. So we need like three competences if we want to generate BPMNs. We need the knowledge of this set BPMN, which I just showed you. Then we also need some generic process knowledge. So the goal is actually for the generator to get some text from the user and then translate that into a BPMN. So it needs to, well, be able to get this text, this prompt the user gives, and, well, dial it down, like make some subtasks, etc. And last but not least, the other goal is actually the MyStacks platform we're building. We haven't spoken too much about it, but it builds up like a whole business context of your business. So we also want to use this business context because then you don't have to type in every detail and everything. We already know a lot about your business, so why not use it as well? So if we go through each of these competences, then we, well, start with the BPMN thing. Why just not ask a large language model to actually just generate the BPMN? There's a few reasons for that. It's just XML, so you think, well, it can generate code as well, and then, well, that works, right? Well, not completely. We tried it with, for example, O1 preview from OpenAI, and after prompting a bit, and then do better, and then again, do better, and then again, do better, then sometimes it gets something that's actually parsable and usable as a BPMN, but it's not trained enough on like BPMNs in the wild. And there are some other problems with that as well. For example, if we go to this image, these are two images which actually got the same prompt. So first of all, we want an image with people facing the camera at a concert, raising their hands with some of these texts. And then we said, well, we have this image, we like it, but we want some other text in there, which is already, I mean, a stretch for image generators, of course. But with the same prompt, we get a completely different image where people are not facing forward. It's not, you don't see their faces anymore. It's actually quite a complete different image. And if we apply this to BPMNs, we can get like two completely separate BPMNs while just changing a small prompt. And if we have something and we want to work from that, it needs to be interactive. We want to modify it and not regenerate it completely, because then we run into these problems. And one additional thing about that is if you have worked with code tooling like Avanti or Cursor or Claude or ChatGPT, Canvas or whatever, and you ask it to make some change in the code, then you will probably realize as well it's relatively good at making changes, but it tends to forget like this import here or this change there. And because the BPMN, these things are so interlinked, changing one part of the BPMN will like not always change the other part of the BPMN, and then you have a broken state. And what do you do with that? How do you work with that? So just generating plain XML from an LLM is not going to work, at least not right now. So what did we do? We thought about, well, how can we make this as simple as possible to generate BPMN? BPMN is really deterministic, so we can already create BPMNs from a CLI, for example. So what do we need? well, actually, we found out that we only need two things. We need to create a task and create a gateway. Because, as we have seen, there's this start event here, and then a sequence flow, as we called, and then we have the task. Well, we can just assume that the BPMN always starts. A process has to start, right? And then if we create a new gateway, well, we can assume that if the gateway has to follow the task, that there is a sequence flow. So there's a lot of assumptions we can make about the BPMN to actually get started and make us a really simple implementation. So there's a lot about function calling. I'll just explain a little bit about how we do that and show it. So here's an example. What we do is we send this function description, basically a sort of doc string, but then a little bit more structured. We sent this to the model, and like GPT-4o supports this, but like there's tens of models, and also most of the models, like the new Llama models, etc., also start supporting tools or function calling. It's named a bit different, but it's a widely known thing around now in the world. And what do? We send like, this is a possible function, the create task, we describe it, and we say, well, these are the properties. You can provide a task name and which previous element. There's some other stuff in the code, but not really relevant right now. And then we get a response. So the response is a response from the agent. It can be either a bit of content, which can just be a message about explaining what it has done, for example. And it can also be tool calls, and these tool calls are actually these function calls. And they are, well, it just describes, I want to call this function, and with these arguments. And then we do something additional, validate that actually the arguments and function call explicitly do as we provided, so that we don't get some weird artifacts with some JavaScript code execution or whatever you can think of. And then also what we do is, when we get it, we just, call actually a completely different function, but we use this to smartly do a lot of stuff in code, like where do we place the task, which sequence flows do we need, everything, all of these things we can assume from what we get. So actually this is what we do, and transform this specific function call with the specific parameters into the next element within the BPMN. So that's that. And then we also want to integrate this business context, the thing you heard Sven also talk about. Context is king. So how do we do that? Well, because of the system we have like a massively structured data set, which we can use. So actually, if I run you through the code as well, it's like software 101 basically, where we just get the different types of context that we really want in the system. We fetch it from our, we know by the structure, we already know which things are relevant. And therefore, we can inject it into the prompt here. I don't think the prompt itself is really interesting. But the thing is, we can provide it with the context. And in this way, we provide us a JSON. But this morning, I learned that if we use OpenAI, that we actually should do Markdown. And if we use Claude, that we actually should do XML stuff, etc. But the good thing is, if you have it in a structured way like this, you can easily just change it from JSON to Markdown, whatever you want. So that's not really relevant. The thing is, where is the context coming from, and how do we know it's relevant? Well, because we have it in structure already. And then last thing, what the generator needs is some process knowledge. So, this is where we got lucky, I guess. LLM agents or LLMs are just really good at dissecting stuff into smaller tasks, etc. It's something that I don't think we can do better than the LLMs itself. So we just use LLMs. So my watch is noting me that this is the 25-minute mark. So I'll hurry up a little bit. So what do we have then? We get function calling together with a business context, together with process knowledge, which results in a generated BPMN. And all of this is in a BPMN agent. And as promised, we have a little demo for that. I'm going to see if I can get this working on the big screen, because I didn't bring a separate mouse. There it is. Oh, spoilers. I'm not going to really dive into what I'm typing here. I just copy and paste this. We are showing you right now, we created an organization for Pygrunn. with some context. And of course, we want to arrange some drinks. And well, it's a different process than we got this afternoon, but that's also the interesting part, of course. I mean, this is how generating stuff works. So yeah, I just prompted it with some stuff. It fetched this context in the meantime. And then with these function calls, it actually, one by one, just said like, okay, I want this task. We need to estimate the number of attendees, then go through this, all these tasks. Well, and eventually it came up with a gateway, which, well, which only has one option. So there are obviously some improvements to make, but it's interesting that there is some gateway. But also the thing is, we don't need it to be perfect, because as you can see, I can just manipulate this immediately because it's just a BPMN which we can work with, and we can just change up whatever we want. So I can add a few options here, a few options there, and work from there. So it's still the human in the loop. That's also, I think people have said a lot of that today as well. Now I'll try to navigate back to the presentation. There. Yeah, I made it. I'll leave it like this. So yeah, now you've seen that we can actually generate stuff, and maybe not really want to brag, but this is to the team. But this is something that's never done before like this. So I want to give kudos to the team as well to say that. But what's next? So we have something here, and you of course you did already see. It's like amazing that the few lines of text I put in there actually result into a BPMN that if you had to start from zero, oh man, I've been there. You have to click like this, oh, that and that. And it's so much easier to just get you started off and at least not have to think about the basic stuff. But we can improve a lot of stuff, of course, because, well, now you have this BPMN, it's not perfect. Can we make it more perfect? Well, we think so, yes. So we need specialized agents. For example, this function calling I told you about. We use ChatGPT 4.0 right now. But I found out that Gemini 1.5 Flash, for example, seems to be like really, really good at function calling and really cheap as well. So there needs to be like some specifics in there. Maybe use a different model for a different type of well, competence actually within this system. And then we also, the option is maybe to even create a customly trained model. So maybe we actually get to a small language model, or maybe a fine-tuned large language model, which actually can generate these XMLs really good. But if we actually make these agents specialized agents, we can actually interchange these competences with newer models and better models if we keep them small, and if we actually know what they are supposed to do, it will help us. One of the other thing is the variations of RAG that Sven already told about. I don't have to repeat that really, but to get this context in there, we might also maybe add like a summarizer for this context. And last but not least, we shouldn't forget about prompt engineering, because I just skipped over all the prompts that we use, but especially for dissecting like this whole idea into like subtasks, etc. Of course, the LLM is good at it, but we could probably win a lot with even better prompts. So yeah, this is the situation I just showed you we have, and this is the situation we should be able to move towards is using three different agents actually. So a multi-agent system to work together and then generate and manipulate BPMN. Since if one gets really good at BPMNs, for example, then you can start manipulating it. And right now, if you use more generic model, that's much harder. So this is the next thing. Well, and of course the future is right now. So I have just a small little bonus demo. Let's see if I can make that work. This is mainly about a demo about the, this is hard to doing two things together at the same time. There it is. This is a demo where I will show you how we use the context, for example, already in a different way, because I just didn't really show you. But now we have the estimate number of attendees task. Well, let's then just generate the description for it. I don't input any prompt. It just happens to do something. And it comes up with information about the task, because it already knows the task, but it also knows the process. It knows like every context, all the context about Pygrunn. In this case, there's not a lot of context in Pygrunn, but it knows all the context. So gets much easier again in this case as well. I should get a new neck after this presentation. It gets much easier to get started and working with and building and modeling your business in this case. So generating BPMN's helping you get started, creating a kickstart to all of this. Well, that's what we do and what you showed you, and how we also think that we can improve this. And then this is a long list of some stuff that might be interesting. And then we have room for questions.